My name is Peterson. I work with Microsoft. And over the next 30 minutes, I'm going to be talking about the Kubernetes Service Catalog. I've got a couple slides. I'm going to do a bunch of demos, so I hope you enjoy. Real quick on the agenda, we're going to first talk about modern application architecture, really kind of lay out the problem statement that I intend to solve with this talk. Talk a little bit about Kubernetes, integrating Kubernetes with cloud providers. We're going to take a kind of a close look at how Service Catalog kind of manipulates Kubernetes or the objects that it creates in Kubernetes. And then I've got a couple end-to-end demos. So kind of before digging into Service Catalog itself, I just wanted to step back, look at an example of kind of a modern-ish application and lay out the problem statement. So if we look at this application here, there's a bunch of stuff going on here, but it's a single application. Basically, the goal of this application is kind of like the canonical example these days, is to pull tweets off of Twitter, gather some sentiment analysis on the tweet, and then present this data in a visually consumable form. So looking at this application, there's actually 6 components to it. 3 of these are running in containers. 3 of them are running in some sort of cloud service. And the way this application works is I've got a container that's pulling tweets from the Twitter streaming API. It's then storing these tweets in a message queue that's not hosted in Kubernetes. It's a message queue hosted somewhere in a cloud provider. I then have another container that's pulling the text or the body of these tweets off of the message queue, sending that body against a text sentiment analysis API, and then storing the results in a database somewhere, in this case, in a cloud provider. And then finally, there's a third container that's just running a little Flask application that visualizes the results. So single application, lots of moving parts, multiple components. Notice they're not all in Kubernetes. So, what I'm trying to get across here is that, applications these days, we don't have just a single binary that's installed on a virtual machine that makes up our application. Applications are deployed across a diverse technical stack. In this case, we've got Kubernetes and a couple Azure services. So while there's a lot of advantages in building applications like this, there's also some challenges, some deployment and management challenges. And we're going to actually take a look at this application today. When I first built this application, I manually started some containers. I manually started some cloud services and then kind of hooked them up together. That's not optimal. I then put together a big script to do it. Better than doing it manually, but still not optimal. And what I found in doing that is I had multiple deployment routines. I was deploying the containers very differently than I was deploying the cloud services. Secondly, I had multiple management tools when I wanted to go and take a look at the application. Is everything up? Is everything talking together? I might pull up the cloud service provider portal or CLI to take a look at everything on the right-hand side here, and use kubectl to take a look at everything on the left-hand side. So multiple management tools. More importantly, in kind of the stuff that interests me, is that I had a secrets management problem. So as I stood up the cloud services, I needed to somehow get the connection information back into Kubernetes so that the containers or the pods running Kubernetes can communicate with the pieces. So I had this kind of like, all right, I've got these cloud things now. I've got to take all the information and manually create my secrets in Kubernetes so that everything can talk. And then finally, the one that I'm very, very interested in right now and spending a lot of time kind of playing around with is instance management. So with this particular application, maybe I'm a provider and I've provided this like a software as a service that you can go and sign up for and kind of one-click deploy your own text sentiment analysis solution. Well, as a provider, I may have 5,000 of these running. And let's say that I need to delete one of those. How do I make sure that I'm deleting the right data store so that I'm not kind of, like messing with other instances of the application running? So pretty cool that we can kind of decompose applications into small chunks like this. Pretty cool that I can have applications that consists of pods running in Kubernetes and managed cloud services running in cloud providers, but some management and deployment issues. I basically just talked through this whole slide, so I'll carry on. So how do we, what's one option for solving those? Before kind of digging into Service Catalog, let's just talk about Kubernetes really quick. And really what I want to do here, I have a feeling we're all somewhat familiar with Kubernetes. I just want to kind of like shift temporarily how we think about Kubernetes for the rest of this talk. We all know that Kubernetes runs containers, runs pods, but I want to make kind of the hypothesis here that Kubernetes can be a platform for running applications and not just the containers and pods that are living on the Kubernetes nodes. Kubernetes has this rich, extensible capabilities through a couple different means. So we've got something called custom resource definitions and aggregated API extensions. Because of kind of the neat nature in which Kubernetes allows us to extend its capability, kind of the capabilities are limitless. And I like to think of, Kubernetes as almost an operating system. And in fact, going back to Matt Butcher's keynote from earlier on, he talked about this a little bit as well. And as we layer in Service Catalog, we'll see kind of some of these capabilities come to light. So the question is, how exactly can Kubernetes integrate with cloud providers? And if I didn't make it clear, kind of the hypothesis that I'm making here is that Kubernetes can be the system that allows me the single system that allows me to manage my applications, whether parts of that applications are running in pods inside of Kubernetes or in kind of hosted cloud services. So how is this possible? Let's step back away from Kubernetes just for a moment, and I'm going to talk through a couple of the components that are involved in Service Catalog, and we'll land back on Kubernetes. The first thing we've got is Open Service Broker. So what Open Service Broker is basically an API specification for a standard cloud provider interface. So basically, hey, if you write your API like this, you can talk to cloud providers. It's a framework for provisioning and accessing managed cloud services. And basically, Open Service Broker specifies 5 operations: provision, bind, unbind, deprovision, and update. So Open Service Broker, a standard way to talk to cloud providers, a standard way to provision resources in cloud providers. With that out of the way, what is Kubernetes Service Catalog? Service Catalog is kind of an add-on to Kubernetes that basically enlightens Kubernetes so that it talks to Open Service Broker compliant APIs. Out of the box, Kubernetes is not OSBA aware, or is not Open Service Broker aware. Service Catalog basically makes it so that it understands, hey, I can natively talk to an Open Service Broker API. When we install Service Catalog on Kubernetes, it basically creates 5 new object types in Kubernetes. So if you're familiar with Kubernetes, an object type, pods, deployments, services. So we have these native object types in Kubernetes. Service Catalog adds 5. Cluster Service Broker, Cluster Service Class, Plan, Instance, and Binding. I'm going to demonstrate most of these in this talk. But basically, I want to focus on kind of the bottom 4. What a class is a offering from a cloud provider, like MySQL. So when I install Service Catalog, we can basically, Kubernetes almost understands like, hey, I'm talking to this open service broker provider, and it's given me a catalog of services in this cloud provider, and MySQL is one of those. That's the class. The plan would be kind of like the tier or SKU of MySQL that you want to deploy. An instance is the intent to provision an instance of MySQL in that cloud provider. And then the binding is the intent to talk to that service. And we'll see those in action. I've also got a diagram that shows all of this together. So we've talked about Open Service Broker compliant APIs. We've talked about Service Catalog. And then finally, but where does this catalog come from? How does Kubernetes know that I want to provision a MySQL instance in Azure? And this is where we get to the actual service brokers themselves. There's a bunch out there. All of the major cloud providers have a service broker. And these service brokers are that Open Service Broker compliant APIs. These service brokers define the catalog of services available to provision from Kubernetes, or we'll see any system that can talk to a service broker. So they define the catalog, and then they actually make the calls to the cloud provider to provision those services. And then, as we'll see, bind to those services, which that binding piece is really getting those secrets, the connection strings, back into Kubernetes so that our pods can use them. So a lot of words. Let's see how this all works out. So here on the left-hand side, we've got Kubernetes with Service Catalog installed. There's a Helm chart for installing Service Catalog. To the right of that, we then have the service broker. In this case, I'll be demonstrating the Open Service Broker for Azure. And then finally, we've got the cloud provider. So Service Catalog talks to the service broker, which then provisions and pulls secrets and whatnot from the cloud provider. The cool thing here is that we can have multiple service brokers installed in our Kubernetes cluster. And then finally, at the end of the day, this is not just a Kubernetes specific thing. So here we've got a diagram with Kubernetes talking to some service brokers, talking to some cloud providers, but because these open service brokers are open service broker compliant APIs, we can replace Kubernetes with something like Cloud Foundry. And we're not kind of redoing all of that logic to talk to those cloud providers. Digging kind of deeper into Kubernetes itself, let's take a look at how this looks. So we've got Kubernetes, the Kubernetes API server, and then we've got our cloud provider over on the right-hand side. Once we install Open Service Catalog, and then we can see the 5 objects created that I talked about earlier. We will then install an Open Service Broker, which again, in most cases, this is going to be like a Helm chart. That Open Service Broker has those classes and plans defined in it. So here are the services that you can deploy into Kubernetes, and here's the SKU or tiers that are available. With that all put together, I can now create a service instance. And what we'll see is creating a service instance, we're building a Kubernetes manifest file. It's just like deploying anything else in Kubernetes. So I might say, hey, I need an instance of MySQL. Open Service Broker then reaches out to the cloud provider, provisions that instance of MySQL. We then create a service binding, which again is a native, or it's an object type inside of Kubernetes. So we can create it just as if we would create a pod or a deployment or a service. What happens when I create that service binding is that the secrets or connection strings or whatever has been coded up is pulled from the cloud provider and stored in a Kubernetes secret. At that point, I can start a pod that consumes that secret and has everything it needs to connect back to the service that I've provisioned in the cloud provider. So that was a lot of words. I got one more slide before we get into demonstrations. I wanted to just quickly throw up a slide about a tool called SVCAT. This is a command line tool for interacting with Service Catalog. It's not a requirement. It just makes it easier to kind of see my service instances and plans and browse the catalog from within Kubernetes. I did want to call this out on the slide because when I first started working with this, I was like, why do I need this other tool? This is supposed to be a native Kubernetes experience. I kind of like scratched my head for a couple days. I am going to use it during this demonstration, but I don't want to kind of derail the conversation because this is really about deploying applications natively from Kubernetes using the methods that we already use inside of Kubernetes. So I did want to call out SVCAT. It's just a convenience mechanism. Finally, I want to come back to this application really quickly. The goal is to manage this application from Kubernetes, just as if I manage anything in Kubernetes. Like, wouldn't it be cool if I could deploy this application using Helm? Not just the pods, not just the containers, but the cloud services themselves. And the answer is that we can do that, and we're going to do that right now. I've got a couple demos planned, actually. I've got docs and samples available. You can pull these from the slides once they're published. So I think the first thing I'm going to do is kind of slowly walk through an instance. We've got this weird, like, we can't see the top line, so just if I get into a state where you can't see what I'm typing, just holler out and I'll fix that. So instead of just jumping straight in and kicking off Helm install of that big application, I think I'm going to slowly walk through a very simple example so that we can see all the pieces as they lay out. So I've got a couple manifest files here. Actually, let's take a look at the infrastructure real quick. So I'm running Minikube on my laptop right here. If I take a look at all the pods running, we've got a couple things that are important here. We've got 2 pods that make up the service catalog itself. So this is the piece that enlightens Kubernetes so that Kubernetes can talk to open service broker compliant APIs. Simple little Helm install. The second piece in here is the open service broker for Azure. Now remember, we can have all the major cloud providers have service brokers. We can have multiple service brokers installed in a Kubernetes cluster. I just happen to be using the Azure service broker here. And again, that was a simple little Helm install. So if I do, I'm actually going to, if I do, okay. kubectl get service classes. Oh. Actually, I'm just going to skip the kubectl pieces. If I do SVCAT get classes, we can see the catalog of services that are available inside my Kubernetes cluster, now that I've got Service Catalog and Open Service Broker for Azure installed. So we can see things like Azure MySQL, Azure Text Analytics. We can also use kubectl to see these, but it's very, in fact, if you just do it, you get these long GUIDs here. So this is where SVCAT comes in handy. It makes kind of these one-off operations kind of easier to run with. And if I do SVCAT get plans, it's quite a bit of stuff spit out here, but we can see like MySQL, I've got a couple here, and we've got basic, memory optimized, general purpose. So basically from within my Kubernetes cluster, I'm browsing a list of cloud services that are available for consumption. So let's take a look at a simple manifest file here. So looks just like kind of any Kubernetes manifest file. We can see here under the spec, I've got cluster service class external name, Azure storage. I didn't call it out, but this was a class available in the catalog. Plan, blob container, and then I've got some parameters here. So location, East US, resource group, and then I've got a name that I want to call the resource group, which if you're not familiar with Azure, basically a resource group is just a container, not a Docker container, but a folder that holds cloud resources. So we're looking at the Azure portal here. You can see I've just got a single single resource group. So I'm going to go ahead and run this manifest file. And again, we're going to slowly walk through a couple steps just to kind of see how this works, and then we'll kick off like the big bad one that deploys that big application. So kubectl create, and then manifest file. All right, so we can see that my service instance was created. If I come over to Azure now and refresh my portal, you can see that I've got a new resource group has been created. If I dig into this, it takes a couple minutes. This is being created. So now back in Kubernetes, let's take a look here. So kubectl get service instance. Okay, we can see that I've got one created there, service instance. So this is a intent to provision something outside of Kubernetes. And just like anything in Kubernetes, I can do like kubectl describe. And we can see an event here that the instance is being provisioned asynchronously. Let's take a look at this with SVCAT. SVCAT get instances. So convenience mechanism there, it's a little bit easier to see. So that's going to provision here for a second. So from Kubernetes, we've created an Azure storage account. That's actually pretty dang cool. Let's go ahead and now look at the binding. So again, another manifest file. It's pretty simple. Kind service binding. Metadata doesn't really matter here. Under the spec, we've got instance reference. So what is the instance that we want to kind of attach to when we create this binding? And that name matches the name of the instance that we just created. And then secret name. So recall that when we create a binding, we're basically going out to whatever we've provisioned, getting the connection strings or secrets or whatever we need to kind of connect back to that thing, bringing that back into Kubernetes and storing it in a secret. And so actually, if we do on this cluster, we can see that I've just got the default secret. So I don't have any secrets here. All right, so let's go ahead and create this. Before we do that, let's see how our storage account is doing. And we can see now that it's ready. So we're ready to bind to this thing. And I actually can, and we're doing this step by step. I could have run this all at the same time. And that binding would have recognized, hey, the instance that I need to bind to isn't ready yet. So I'm just going to kind of wait until that's provisioned and ready. Once it is, cool, now I'll go ahead and create the binding. All right, so my binding is in the process of being created. And we can see that it's ready. So SVCAT get bindings. We'll actually take a look at this. So get secrets, so we can see I've got a new secret that has been created. Let's go ahead and take a look at this secret. All right, so we can see that we've got three secrets stored here. Access key, container name, and storage account name. So let's just like prove out that this has actually worked. So I'm going to copy out that access key. And decode it. So this is basically the access key for that storage account. We can see that it starts with WQE. So let's go back over to my Azure portal. Here's my storage account. And if I go to access keys, boom, WQE. So we can see that Kubernetes secrets are only as secure as they are, which isn't very secure. But we can see that we've actually pulled the connection strings from my Azure Storage Blob into Kubernetes. So the final piece is then using that. So I've got just basically a simple little application here. So we've got a deployment with this image right here, which basically has a simple little application that writes a file named hello OSBA to a storage account. I'm then grabbing the credentials for that storage account from the secrets that we just created using the service binding. And then and these are just stored as environment variables, and my application knows to grab those environment variables and then do its work. All right, so let's go ahead and create that application or create that pod. And we can see that it is running. So if we come back over here to the Azure portal, we can drill into this storage account. And there's my hello OSBA file. Just to kind of prove out that this is doing what I say it's doing. Ooh. Just go ahead and delete that file. Basically, that pod, the application inside that pod is just looping, making sure that file exists. And if it doesn't, it's going to recreate it. So we walk through each of those steps manually, or slowly, step by step. But what we saw is that we just provisioned something in Azure. We bound to that something by pulling the secrets into Kubernetes, and then we accessed that something from within a pod that we started in Kubernetes, and there's that file. So let's kind of like ramp it up and go back to my kind of big application that we saw. And I'm actually going to cheat on this one and just copy out my Helm install string here. Now, this does take a couple minutes to provision, about 5 minutes, so we'll see how far we get, but we'll definitely see some stuff happen. So Helm install, I've got a chart that we'll take a look at it here. -F, I've got a values file in here that just basically contains the keys to access the Twitter streaming API. Set filter text. So this is the text that I want to search for in tweets as they're tweeted, just London. And then set minikube equals true. There's some, I'm storing the data in an Azure Cosmos DB. There's just some firewall things that need to be configured that I set up in the Helm chart. Let's go ahead and run that. And so we can see here now that a lot of the things that we just talked about were just deployed. So here is my service instances. So within that application, I'm provisioning a storage queue, an Azure Cosmos DB, and an Azure Text Analytics API. I've then got the bindings for all three of those things. And then I've got my deployments or my pods. So if you recall, there were 6 components to that application, 3 cloud services, 3 pods. There they all are. If we come back to Azure, I'm going to go ahead and refresh this. Oh, there it is right there. Twitter-sentiment. And there's actually my 3 services. They look done here, but that Cosmos DB does take about 5 minutes to provision. We can see in Kubernetes, SVCAT get instances. Here are those 3 cloud offerings, and they're in a provisioning state. We can see that we've got 3 bindings, but they are not ready. There are a couple little rough edges around SVCAT, or I'm sorry, Service Catalog. So we can see ready state is error instance not ready. You know, first time I saw that, I was like, oh, something's going wrong. Well, really, it's just that, you know, there's not really an error. It's just kind of waiting for those instances to be fully provisioned before it creates the binding. And while we wait for that, let's just take a look at the Helm chart real quick. So I won't go through every step, but what I wanted to kind of show is that, yeah, we just have a big Helm chart here that has everything we've talked about kind of configured out in it. So we can see service instance, class, Azure storage, service binding. So once we provision that Azure storage, we want to bind to it. We've then got a deployment that consumes the binding results. I've got another service instance, class, Azure Text Analytics, service binding. So once I have the Text Analytics API, I need to be able to make calls against it. So I need to get those secrets in. Another service instance, class, Azure Cosmos DB. Once I provision the Azure Cosmos database, I need to be able to access it. So let's create that binding. And then finally, deployments. So all my pods. So that said, let's see how we're doing. So we can see some of them are ready. One's still provisioning. It's that Cosmos DB one. And my bindings are still coming along. So while we wait for this to finish up here, just want to talk about some of kind of my observations as I've been working with Service Catalog. I already called it out. There are a couple little rough edges. Some things will throw up an error, but it's really just kind of like waiting to provision. Finally, another big one is the open service brokers, or the kind of cloud provider specific brokers. They're independent of like Kubernetes itself. And just because, and they're kind of hand coded. So just because Azure has 35 services, the service broker itself only has a couple. In the case of this application, like the text analytics service is not in open service broker for Azure, so I had to go develop that myself. I've got an open PR right now to get that submitted into the open service broker for Azure project. But basically, it is a work in progress, and not everything is there. The other kind of thing that I find interesting is, as we've moved to running applications in containers start really quickly. But as we can see here, like this application is not fully running in a container. We've got other cloud services involved. So we can see here that I've kind of got a time delay between when I say go and when my application is ready. So I found that interesting, hey, we've moved to like, everything starts immediately to like, well, some of these things take some time to provision. All right, so my service instances are there. My bindings are still being created. And this stuff is all being spun up at this point. I think I'm not going to wait for this provision. I've got some videos on YouTube that kind of show this end to end, but everything is coming up. I think we're at time. So I hope that was helpful. Thanks for attending my talk. I don't think we have time for questions. If you do have questions, feel free to find me. Appreciate it.